Hello everyone, welcome to Digital Electronics and Computer Organization course. I am Sudhakar Ajmera, Assistant Professor, Department of ECE, MLR Institute of Technology, Hyderabad. And today I am going to discuss about number-based conversions in digital electronics as a part 2. In a part 2, I am going to discuss about decimal and hexadecimal number system conversions. As a part 1, we have discussed remaining two number system conversions. They are binary number system conversions and octal number system conversions. As a part 2, we are going to discuss about decimal and hexadecimal number system conversions. As a part of this, today's lecture, I am going to discuss about first decimal to any other number system conversions. Okay, as you know about in previous sessions, we know about all the number systems, definition of number systems, what are the types of number systems and so on, importances, applications and all. And today I am going to discuss about this decimal to any other number system conversions. So as a part of this overview of today's topic, first one is decimal to any other number system conversions and next one is hexadecimal number to any other number system conversions. As a part of this decimal to any other number system conversions, first I'm trying to convert decimal to binary, then decimal to octal, then decimal to hexadecimal conversions we'll see. Thereafter, I'm going to cover as a part of hexadecimal conversions, we'll see hexa to binary number system conversions, then hexa to octal number system conversions, then hexa to decimal number system conversions. So first let me see decimal to any other number system conversions. So as a part of this decimal to any other number system conversions, first one is decimal to binary conversion we'll see. As a part of this, let me convert some quantity in decimal. I am trying to take 123 point something 21 in decimal. I am going to convert this in binary. I don't know about this. So while converting from decimal to binary, we have to see this number has two parts. This part is integer part, integer is 123 and this one is fractional part. This one is integer and this one is fractional part. So what is the fractional part value here? 0.21. Okay. So for this two integer and fractional part, I have to do different process. Okay. So while converting from decimal to binary conversion, I need to divide integer part by 2 and multiply fractional part, that is 0.21 with 2. So let me first convert this integer part. So divide this integer part by 2 in this process. Then what is the remainder here? 261 is 122. Remainder is 1, like this. So 231 is remainder. So 0 is remainder. Then here 1 is remainder. 2, 3 is 6. And 1 is remainder. So 2, 1 is 2, 1 is remainder. For fractional part, as I said just now, to convert fractional part into binary, I must multiply fractional part with 2. So multiply this fractional part with 2, 0.21 with 2. So what is the quantity? 0. After multiplication 0.42. So while multiplying, you have to observe this part, integer part again. So you copy here the zeros and take this part again this side and this will become 0.42 into 2. Again you multiply with 2. Okay, as long as this fractional part becomes 0. So 0.42 into 2 means 0.84. So again I got this integer part as 0 and multiply, okay, this, copy this fractional part here and multiply with 2. Again you multiply. So what will get it is 2 4 8, 2 8 16. So I got this one. So in this case, this integer part copy here and you copy this fractional part, again 0.68 into 2. Again you multiply. So 1.36 I got it. Okay, 1.36. So again you take this integer part here and this fractional part again here. Then again you multiply. So this is 0.72. So here this integer part copy and this fractional part again you multiply with 2. So from this, what I mean to say, I hope this is a never ending process. Okay. So here in this case, okay, if you keep on multiplying, okay, this fractional part will, okay, for this case this fractional part will not become 0. So it's a never ending process. In that case, okay, there are so many samples here also. So leave as it is. Okay. Now what is the actual answer for this one is, while writing answer, you copy integer part from down to top side and fractional part from top to downside. Now actual answer is, for this 123.21 in decimal is equal to integer part is, as I said, copy from top to bottom. So 1111011 dot, and here fractional part, as I said, you copy it from top to bottom. So 00110 and keep on it moving, right? So it is in decimal quantity. So now number is converted from decimal to binary. So this is the decimal number and this is what? Binary number. So this is the process I need to convert from decimal to binary. Now next one is decimal to octal. Octal number system. Octal number system. As a part of this, let me take same example. Convert any decimal quantity like 123. Okay, 1 2 something 1 2 in decimal. I need to convert this into octal. I don't know this quantity. Okay, this decimal can be converted into octal. Same process what we have followed in the previous case, like decimal to binary, same here also we need to follow. So while converting from decimal to octal, I need to first identify, okay, integer part and fractional part. So this is the integer part. I must copy paste it here 123, and this part is fractional part. So this is what? Fractional part. So 0.12 is fractional part. So the same like binary conversions I have to follow for this decimal to octal number system. So here 123 will be divided by 8, because as I said in the previous case, while converting from decimal to binary number system, divide integer part by 2 and multiply fractional part by 2. But whereas for decimal to octal number system conversions, I need to divide integer part by 8 and multiply fractional part by 8. So first let me finish this 3 remainder here. So 8 1 8 and here 7 is the remainder. For fractional part, if you do it, so 0.12 into 8 will give here 0.96. So here I need to copy this integer part here, and again you take this fractional part here 0.96 into 8. So again you multiply. So this is what? 7.38. So you copy this 7 here and this 0.38 you copy here. Again you multiply with 0.38 with 8. So this we got here 3.04. So you again copy this 3 here and this 0.04 you copy it here. Okay, so this is what? 0. So I hope this is also never ending process. So continue as many samples as you want. While converting from decimal to octal, you take integer part from down to top and fractional part from top to bottom. Then write the answer. So now 123.12 in decimal equivalent is, this is 173 point, you have to take from down to top 173.0730 and there are the samples here, because as I said this is a never ending process. Okay, then write octal quantity here. So like this I can convert from decimal to octal. Now while converting decimal to hexadecimal, same process I have to follow. So for example, let me take 123 point something 12 in decimal, I must convert it into hexadecimal. So here while converting decimal to hexadecimal, I need to again find out integer part and fractional part separately. So here integer part is 123 and fractional part is 0.12. So while converting from decimal to hexadecimal, I must divide integer part with 16 and multiply fractional part with 16. Same process I have to follow. So here, so 16 7 112, 16 7 112. What is the remainder here? So here 11 is the remainder. So like this I have to do. For fractional part, I have to multiply with 16. This is what? 1.92. Here same process I have to do. Integer part I have to copy it here and fractional part I have to again take it here and multiply with 16. So what is the answer I got it here? 0.92 into 16 is 14.72. So 14 I have to copy it here, again 0.72 I have to copy it here. So what answer I got it? 11.52. So again 11 I have to copy it here and this fractional part I have to copy it here and multiply with 16. So now what I got is 8.32. So again this 8 I copied here and this 0.32 multiply with 16 I have to copy it here, will give 5.12. So here 5 I have to copy it here. So how many repetitions I want till this fractional part becomes 0? I have to repeat it. So I hope this is also never ending process. Now while taking integer part, I have to take from bottom to top, and for a fractional part I have to take from top to bottom. So the final answer for this 123.12 in decimal is equivalent to 711.114.11.85 and so on. This is converted into actual, but here one thing we have to observe is not yet finalized answer, because here symbol 7 is belonging to hexadecimal, but 11 is not the symbol of hexadecimal. But what is the equivalent of 11? Here A is 10, B is 11. So here instead of 11 I need to write in hexadecimal it as B dot 1. 14 is what? So A is 10, B is 11, C is 12, D is 13, E is 14. So 14 equivalent is E. Like that 11 equivalent is B. Then 8, 5. Now this is the perfect answer for decimal to hexadecimal conversion. So next we will see hexadecimal to any other number system conversion. As a part of this we will see hexa to hexadecimal to, we will see binary conversions. first. As a part of this, let me take an example. Convert any hexa quantity like 1B 2 dot something 2A. Okay, this is what hexadecimal quantity. I need to convert this into binary. So here what I need to do while converting hexadecimal to binary, I have to take each hexadecimal quantity, each hexadecimal digit and make group of 4 binary equivalents. So now 1 can be written as 0, 1, 1 and this B can be written as, B means what is the equivalent of B? 11. So B is 11. So 11 equivalent in binary is 1, 0, 1, 1. This 2 equivalent is 0, 0, 1, 0. Next dot, this 2 equivalent is 0, 0, 1, 0. Then A means what? In hexadecimal equivalent is 10. So 10 I can write with 4-bit equivalent in binary is 1, 0, 1, 0. So this is how I need to convert in binary. Now final answer is, so 1B 2 dot 2A in hexadecimal equivalent is 0, 0. Copy as it is here. 0, 0 and club it. 0, 0, 1, 1. 1, 0, 1, 1, 0, 0, 1, 0 dot 0, 0, 1, 0, 1, 0, 1, 0. This is what? Binary quantity. Because why I need to make 4 bits equivalent while converting hexadecimal to what it is, binary number system conversions, because hexadecimal base is 16 can be written into 2 power 4. So I need to make 4 bits equivalent in binary. Next, as a part of hexadecimal to any other number system conversion, next conversion is hexadecimal to octal conversion. We'll see. So let me take an example. Same 123.1A. 1A in hexadecimal. I need to convert it into octal. So while converting hexadecimal to octal, first convert this hexa into binary, then convert that binary into octal. So now while converting hexa to octal number system, first convert it into binary, then binary to octal is easy. Now here how I can convert this 123.1A into binary? Same process like previous one. So here I need to identify integer part and fractional part, and same process we have to follow. So here integer part is 123 and fractional part is 0.1A. Let me take easy example. Okay, fine. How I can convert into binary? Here hexa quantity, how I can convert into binary? By making 4 bits binary equivalents of each octal digit. So how I can convert this 1 into 0, 0, 0, 1. This 2 I can convert into hexa 0, 0, 1, 0. This 3 I can convert into binary 0, 0, 1, 1. Next this one 0 point, this 1 can be converted into 0, 0, 0, 1. This A can be converted. A means what? It's a 10. It's a 10. So 4-bit equivalent of 10 in binary is 1, 0, 1, 0. Now actual answer is 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1 dot, I am clubbing this integer part and fractional part 0, 0, 0, 1, 1, 0, 1, 0. This is what actually binary. Now I can convert it into octal easily. How? By making 3 bits equivalent. in integer part and fractional part. While making grouping of 3 bits equivalent in integer part, I have to start from right to left and make 3 bits equivalent, and in fractional part I have to start from left to right. So here 3 bit equivalent is this one, and here 3 bit equivalent is this one, and here 3 bit equivalent is this one, and here 3 bits equivalent is this one. So here sufficient bits are there. While making grouping, if sufficient bits are not there, I have to add as many zeros as I want at extreme left side of integer part and zeros at extreme right side of fractional part while making grouping. So here these 3 zeros, 1 1 0, then 1 0. Here sufficient bits are not there, so I need to add one more 0 here. Now I can group it. So 0 0 0 is 0, 1 0 0 is what? It is 4, then 1 0 0 again it is 4, then 0 1 1 it is 3 dot. This is 0, this is 1 1 0 is 6, and 1 0 0 is 4. So now it is converted into octal. So now actual answer is, for this one is 123.1a in hexadecimal is equivalent, a in octal is 0443.064 in octal. So keep it in mind, while converting hexadecimal to octal, first convert hexa quantity into binary, then binary to hexa, binary to octal conversions. Now last conversion is hexadecimal to decimal. So as a part of this, let me take an example. Convert any hexa quantity, I need to take it. So let me take 108 dot something B2. This is what hexa quantity. I need to convert it into a decimal. I don't know this decimal quantity. This quantity I don't know. It's a hexa quantity. So while converting hexa to decimal conversions, I need to multiply these coefficients with corresponding base weights. So what are the coefficients here? So 1 0 8 dot B2. While converting hexadecimal to decimal conversion, I need to multiply this coefficients with their corresponding base weights. So I have to take here corresponding base weight of this 8 is 16 power 0, this 0 is 16 power 1, and this 1 is 16 power 2, and here for this B equivalent is 16 power minus 1, this 2 16 power minus 2. So now I have to multiply, but here B is actually in hexadecimal, B is 11. So here I have to multiply. So 1 into 16 square plus 0 into 16 power 1 plus 8 into 16 power 0 plus this 11 into 16 power minus 1 plus 2 into 16 power minus 2. So what is the equivalent here? 1 into 16 square is 256 plus 0 into something is 0 plus 8 into 16 power 0 is 8 into 1. Anything power 0, the 16 power 0 is 1. So 8 into 1 is 8 plus 11 by 16 plus 2 by 256. So what is the equivalent here is 264 plus 11 by 16 is 0.6875 plus 2 by 256 is 0.0078125. So let me add this quantity, will give 264.6953125 in decimal. Like this I can convert hexadecimal to decimal conversion. This is the equivalent of. So now I want to conclude. So like this we can convert 108 dot B2 in decimal quantity is equivalent to 264.6953125 in decimal. As a part of this, we have seen today is decimal conversions to any other conversions, any other number system conversions, and hexadecimal to any other number system conversions. And in next topic, we are going to see about complements. In next topic, we are going to see about types of complements and their conversions. Thank you.